Let's begin. Today is June 8th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So again, today's puzzle uses the following 5 criteria cards: 5, 10, 16, 19, 20, and uses the blue verification cards. The unique code above here is your way to get more details on today's puzzle by going to turingmachine.info. Let's solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C, and at the bottom row, we've got criteria cards D and criteria card E. If you look at criteria card A, this looks at the first digit, the triangle digit, and will let us know whether that value is an even or an odd. Criteria card B will look at the 3 digits in our code and will let us know how many of those should be 4. Are there no 4s? Is there a single 4? Perhaps 2? Maybe even all 3. Criteria card C again looks at the 3 digits in our code and will let us know how many evens to odds there are. Should there be more evens than odds or less even than odds? Criteria card D will take a look at the first 2 digits, triangle and square, add them together and compare that to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again looks at the 3-digit code and tells us a little bit of how the structure of it, so to speak. Of the 3 digits, are there no repetitions, meaning that all digits are unique, like the example 125, or is it a double number in that it has a repeating digit, as in the example 112, or potentially it's a triple number, which means it's a single digit repeated 3 times. Remember, our objective is to find this unique 3-digit code that abides by the criteria cards that we've just discussed. And we're going to start off with our proposal of 314. So the first thing I want to test is I want to know if that first digit is an even or an odd. So I'm testing criteria card A. Okay, so the Turing machine responds that it does not approve of what I have in my triangle value. So notice that I do have a 3 for triangle. Since the Turing machine does not approve of that, basically it's telling me that triangle should be an even digit. So that's what I'm going to write down in my notes in section A, that triangle is an even digit. And since it is even, I'll cross out all the invalid odd values. Okay, and let's take a look. Since we already know that triangle is even, let's actually test criteria card C, since it'll let us know how many even to odds there are. Okay, so it approves of the proposal 314. Notice that I do have 2 odds to 1 even. The Turing machine approves of that. So let me go ahead and write that down in my notes for section C, that even should be less than odd. Okay, and since we do know that triangle's an even, that means the remaining 2 must be odd. So I'm going to write an additional note here that square and circle are odd. And so since they are odd, that means that I can cross out all the evens in their respective areas. So square and circle can no longer be 2s or 4s. Okay, so far so good. So at least we have this general idea that we have even, odd, odd. And let's take a look what else. Well, if you notice that criteria card B will let us know that how many 4s there are. Obviously, there can't be 3. There can't even be 2 of them. So it's either the 4 is there or the 4 isn't. Since it's sort of 50-50, I think I'm going to skip it, since I know I can always figure that out in the next turn. I think I'd rather find out a little bit more about what triangle and square are. So one thing that we can say is that I don't believe you could ever get 6 for the sum of triangle and square, because typically you need either 2 evens or 2 odds. And since you already know it's an even for triangle and a square for, odd for square, that means it can never be a 6. Okay, so at least now if we test this, if it succeeds, great. If not, then, well, we know it's the other third option. So let's go ahead and test criteria card D. Okay, so it does approve of the proposal. I do have 3 and 1, which its sum is 4. So that's what I'm going to put down in my notes for section D, that triangle plus square must be less than 6. Okay, and so what does that tell us? Well, I don't think square can ever be 5, because 5 plus 2 and 4 are already greater, so it can't be a 5. What else? Anything else? I think we can keep the 3, because you could always add it to 2, and you can keep the 4 because you could always add it to 1. So it looks like there are several possibilities. 2 can be used for either 1 and 3 or 4. But actually, let me just state that since we already did our 3 tests for this round, the next phase is what I was doing was I was already thinking of what could the final solution be. So I'm trying to construct a second round proposal. Okay, so as I was saying, 2 would work for either 1 and 3, and 4 would only work with 1. Let's take a look. I did not test criteria card E, which would let me know whether there were any doubles or repetitions. Obviously, there can't be a triple number, since again we do have 1 even and 2 odds. As far as doubles, it would have to be 1 1 or 3 3, which, you know, for all intents and purposes, they both work. And but it could be that they're all different. And so let's take a look at what. So again, we know that criteria card B will let us know for sure if it's 2 or 4. And obviously that sort of dictates what square would be. For instance, if it is a 4, then the only viable value for square would be 1. And so what would happen there? If it's 4 1, could it the only way I think we could differentiate between 1 3 and 5 is if it were a double, because 4 1 3 and 4 1 5 just doesn't you can't differentiate those two codes, because how would you distinguish 3 and 5? I just don't see that happening for circle, because they're both different. So it looks like, let me see, B, yeah, so let me start writing some of these potential solutions here in B, since I know it's either, so again, if it is a 4, it could only be 4 1 1, because again, there's no way to differentiate between 413 and 415. There's nothing here, if you notice in our 5 criteria cards, nothing about circle. So you would almost have to force it to be something, and the way to force it would be if it was a double, a repeating digit of 1. And I think that's the only possibility with a 4. Because, yeah, 4-3 does not work because of criteria card D. Okay, so then what about 2? Well, it could be 2-1. And again, if it's a double, it would be 2-1-1. And if it's not, I think, again, there's no way to differentiate between 2-1-3 and 2-1-5 for the same reason I mentioned before. You cannot distinguish them. Okay, so that was kind of short. And the alternative would be 2-3. And in this case, well, yeah, I think for the same reason, 2-3, it would almost have to be 2-3-3 because of the double. Because 2-3-1 and 2-3-5, how do you distinguish between them? 2-3-1 and 2-3-5. Yeah, I don't see it. Well, it looks then that there is a double. They all have a double, so I don't think we need to test necessarily criteria card E. So what would make these different? Well, the only thing that makes them different is that 4-1-1. Could that be the final answer? Only doing one round? Yeah, that circle theory that I have been stating seems sound. How do you pick that circle? You can't. I think that's it. I think that's the solution, 4-1-1. Wow, I am pretty surprised that it only took one round, 3 questions. Well, let's go ahead and test it. So I'm going to write down the answer of 4-1-1, and let's go to turingmachine.info and verify. So 4-1-1, and let's verify. Awesome. Wow. That was very impressive how we only needed to do A, C, and D. Okay, so I'm pretty confident that we beat the Turing machine. So A was incorrect, and then C, D were correct. So let's go ahead and put that in. So A was incorrect, and then C and D were both correct. Awesome. Wow, look at that. Yeah, not only did we do it in one round, obviously, that's a smallest number of rounds you could do, but it even took the Turing machine 6 tests to do it. Well, it's hard to say whether there is an element of luck. I'm sure there is. I don't know how to quantify it. Perhaps I got lucky with my initial proposal of 3-1-4. It could have been, the order and the actual criteria cards that I selected. So yeah, there's definitely some amount of luck. And before, I guess, maybe I should have crossed these out. Okay, so 4-1-1 was the accurate solution. Well, if you liked today's puzzle and video, please give it a thumbs up. If you don't want to miss out on future videos, please hit subscribe to be notified. Well, until next time, have a great one.